In this work, we present a method that actively localizes a contact between a grasped object and its environment, then applied to the peg-in-hole insertion task. A misalignment between peg and hole leads to the contact between them, which can be sensed with a tactile signal. We use this tactile signal to find the contact line that the object can pivot around. Then, we use this estimated contact line as input to the insertion policy trained with reinforcement learning. With such method, we were able to insert various unknown objects to unknown holes. We use a factor graph to fuse the information of robot motion and tactile measurement. The factor graph works collaboratively with an active tactile feedback controller that attempts to pivot the object around the external contact. Also, by using contact line as input to the insertion policy, we can train the policy in simulation and ease the burden of collecting data in real experiments. Let's dig into more details. First, the tactile sensor captures the deformation between the grasped object and the external environment as a high-resolution tactile image. We then convert the deformation image to the gripper object relative pose. The factor graph incorporates the relative pose and the robot motion to estimate the contact line, which is indicated as the red line. At the same time, the active tactile feedback controller regulates the extrinsic contact configuration to be consistent without slipping. Then, the reinforcement learning policy computes the planar displacement for the next step to guide the insertion. The blue rectangle indicates the current pose, and the green rectangle shows the candidates for the next pose. The policy has the recurrent architecture, so it considers not only the current attempt, but also the history of previous attempts. Now let's take a deeper look into the active tactile feedback controller. The controller attempts to pivot the object about the contact line while avoiding slipping and maintaining a constant tactile feedback. The key idea is the synergistic interaction between the controller and the factor graph. A better contact line estimation helps the controller to pivot the object with less slipping, and a better pivoting around the consistent axis helps the factor graph to get a more accurate contact line estimate. With such a tactile feedback, the estimation is more accurate than when we do not use the tactile feedback, both in horizontal and vertical direction. We can see that the gripper object relative pose is more consistent. Also, it shows the less slipping between the object and the environment. Thank you for listening, and please contact us if you have further questions.